interpreter can say, tag, well, you were using X here, and you should not be using Y here. Do you think any tool can make that association and interpret the code and say, oh, you store the result back into X, you should be using X instead of another global variable? Probably not. Okay? So this is still not as good as it can be because X is what we call a intermediate variable. Its only purpose of life is to link the result of one line to how we want to utilize it on the following line. Okay? So if there's a way to utilize the result of the invocation of a subroutine directly, it's even better. Are we doing okay so far with the concept? Okay? In other words, we want to be able to do some calculations and have a subroutine itself to say that, oh, when you invoke me, I will give you an answer, and here is the answer. Use it right away for whatever you want to use it for. Okay? So that's what we're going to talk about next, which is what we call a return value. So here's a new sample program using return values. And we'll start with something that is pretty trivial, but nonetheless, it does demonstrate the mechanism of returning values. So we'll go ahead and define sub. Let's call this one 7. And we'll make it return a constant of 7. And define sub. So this return 7 is a type of statement that we have not seen before. And that's the whole point of this sample program, is to illustrate what do we do when we have a return value like that. And just for fun, we'll have another subroutine to return 5. And it returns the value of 5. Okay? Just to make sure that we understand that this is not, it's not a program automatically associating word 5 to the value 5, we'll change this one. Instead of 5, we'll say wu, which is the Mandarin for the value 5. I just want to make sure that we don't accidentally think that the name of the subroutine implies the value that it is returning. Okay? If someone wants to change this to Spanish words or French words or German words, feel free, do it on your own version of the notes. So we just want to make sure that it's not automatic. It's not an automatic association. Okay. Now let's go ahead and define what we call a main subroutine, and I'll explain what a main subroutine is later on. But in the main subroutine, we do one thing. We say we want to print. Now this part is going to get a little bit interesting. Invoke 7 times invoke wu. Okay. And define sub, and we have a single invocation of main at the outermost portion of this program. There are several things to talk about with this particular sample program. The first thing is the concept of a main program. Up to this point, we always start with the line of code that is outside of any definition of any subroutine. In this case, that line is line 10. And it invokes a subroutine that is strangely named. It is called a main subroutine. And that's because when you move on or transition to cisp300, you don't have control of any line that is outside of the definition of a subroutine. You can only define your code inside a subroutine. Okay? And you guys are kind of following me? In C and C++, the only place where you can specify a line of code like assignment statements, invocations, and whatnot is inside a subroutine. You cannot specify any code outside of the definition of a subroutine. So how do you know where the execution is going to start? Well, they have a magical name for a subroutine called main. All execution will start with the main subroutine in a C program. So that's why I'm changing the standard a little bit here to basically say that this invoke main is not your line. When you write a C program, you cannot write line 10 here, okay? Because you have no control over anything that is outside of the definition of a subroutine. This line is implicit, and it is always there. With any C program, there's always an implicit invoke main somewhere in the program. As far as you are concerned, your entry point of execution is the main subroutine itself. Okay? So I'm just making this transition here so that by the time you get to cisp300, you won't feel that, oh, that is kind of strange. How do I specify the entry point of my code? Well, it is called a main subroutine. So, so that's the first thing. But even more strange than the main subroutine, which is nothing more than saying that line 10 is implicit and you have to define the subroutine main, is line 8. Line 8 looks awfully strange to me because not only do we have an invoke, after the print, we have two invokes after the print, and they are joined by a multiplication symbol. Can someone kind of just give me a guess of what this program is supposed to do? Without worrying about the mechanism of doing it, what do you think it will do? It will print 35, right? Okay. So it will print the product of 7 and 5, because one returns 7, the other one returns 5, and as a result, this will become 7, this becomes 5, we print 35 as a result. So we kind of have an idea of what it is supposed to do, but we don't have an idea of the mechanism that is going to do it. So the mechanism of doing this. Let's go ahead and take a look at the mechanism of doing this, and we'll take a break, after we talk about the mechanism, so that we have some time for that concept to sink in. So I'll call this simple return value. In this case, we don't need I guess we do need comments because we have a print line, but we won't need it until much later. So I'm going to scroll it off the screen just so that it does not add to the confusion. The first line we execute, there's nothing to talk about in pre. I don't have a single variable whatsoever in this case. Instead, we start execution on line 10. Line 10 is a subroutine call. We have return line number being post in this case because there's nothing after line 10. Okay, so that part is not a big deal. And after we get into the subroutine main, we get to line 8. Okay, can someone tell me what I should do first on line 8? Can I print right away? There are 3 actions. Okay, there are 4 actions that we have to do, right? If you just look at line 8, it suggests that there are 4 actions involved. Print is one action, invoke is one action, multiplication is one action, and invoke is another action. So there are 4 actions that I have to perform on line 8. Can I print without the other actions taking place first? No, because I don't know what to print. Can I perform the multiplication first? No, because I don't know what I'm multiplying. So that means the first thing I have to do is to either invoke 7 or invoke move, right? Does that make sense? Yeah. Now, in this case, you truly can choose which one you want to invoke first. Okay, you can invoke 7 first, or you can invoke woo first. But because most people read from left to right, we'll follow that standard and we'll invoke 7 first. Okay.
Dr. Tack?
Yep.
Is it bad programming practice not to put an extra pair of parentheses on the outside of those two in the same way that you would do with mathematics, straight math, like straight algebra?
It's kind of implied, that we don't need an extra parenthesis on the outside because I'm not doing anything with the product of 7 and 5.
Okay.
I'm just printing it out. So
but what if you had this is relatively simple. It's just multiplying 2 values, right? What if you had something that was more comprehensive? I don't know, linear equation or something like that, with some other operations.
You can add parentheses as you need, the extra levels of nesting.
Right.
Yep. But in this case, we don't need to use it.
So it's going to multiply before it prints?
Yes, it has to multiply before it prints, right? Or if you guys prefer, we can always just add that. It's easy enough. But in most cases, this is implied. Most programmers understand, that the extra pair of parentheses are not actually needed. Okay. So the question now is, I'm going to invoke, 7 first, right? Okay. Do you guys agree that we have to invoke 7, and then we invoke woo, and then we do the multiplication, and then we can print? Okay, that's kind of the right order of doing things. So we'll go ahead and invoke 7. Now, just like with invoking anything, we need to know where to return to. But there's a problem with a return line number notation here. If I use return line number, what would you put here, where the cursor is at this point?
8.
Okay, you would put 8. Now, that means when I'm done with the subroutine 7, I go back to line 8. Does it tell you which part of line 8 we have to do next? No, it just tells you that we have to continue execution on line 8, which in our usual way of doing things, we start from the beginning of the line again, which means we're going to invoke 7 again, it will return back to line 8, and then we do the whole thing again and again and again. So that's why we have to change the way we remember where to go back to. Instead of calling this a return line number, now we call this return info or return information, because it is more extensive than just a line number. I still have a line number. I still have to remember which line I'm supposed to go back to, but then I also have to remember what else on that line I'm supposed to do. Okay? So that means I have to copy the entire line of line 8. I have to remember I have a print operation that is not done yet. I'll explain this part later. I know that I have a multiplication I have to do. I also remember that I have another invocation of woo that I have to do. This is how we keep track of what else we have to do on a line when we use a return value. So let's kind of go back and talk about this question mark here. The question mark is replacing the invocation itself. Okay? Because we are invoking 7 in this case, so invoke 7 is now replaced by a single question mark. The question mark serves as a placeholder of the return value of the subroutine. Okay, so it may not look very clear why we have a question mark here, so let's just go ahead and go into the subroutine, because the next line of the trace will demonstrate why we have this question mark here. The next line to execute is inside the subroutine. The first line that is in action is line 2. It says return 7. So now, what do we do when we specify return 7, when we execute return 7? Yep. Exactly. But to avoid any confusion, we copy and paste this entire line and then change the question mark to 7. We do not destroy anything.
Yeah, not like we do normally.
Right. Well, we actually do destroy this line here, but we still remember that that line will look like this by the time we get back to line 8. Okay. So is this clear? From row 6 to row 7 of the trace, do we know what has just happened between these two rows? The return statement, or line 2 in this case, a return statement does only one thing. It copies whatever the return info has to the cell next to that row, and then the only thing it has to do is to find out where the question mark is, and then replace the question mark with the value that I'm returning. In this case, it is 7. Are we doing okay with this mechanism? Kind of. And the rationale behind this